All right, greetings, Saintsmen. We're working on triangle similarity through the angle triangle similarity postulate. So here's what we've got. When we have angle AA similarity is going to state the following. Now, remember, when we were dealing with the similar polygons, right? Two polygons that were similar, all the corresponding angles were similar. Were congruent. Every single one was congruent. So here's what angle similarity states. It states this. It's that if two angles of one triangle are congruent to two angles of another triangle, then triangles are similar. Here's the best part. We don't really need all three angles. Remember what we would have said here. And let me show you guys an example, in other words, of what this looks like. Let's say we have this triangle here, right? Doesn't matter the type. But then we have another triangle, which is going to be similar, okay? All we need to know in these two triangles is this. If we have A, B, C, and D, E, F, as long as A and B are congruent to D and E, in other words, if angle A is congruent to angle D, and angle B is congruent to angle E, then our two triangles, ABC and DEF, are similar. Remember, we mark similarity through the single squiggle right here, right? So, why do we only need that much information? Remember the beauty of this course and of logic. It's where we're going to prove more with less. We don't need to have, for example, when we do congruence, you don't need to have every single corresponding angle, right? Or every single corresponding angle and every corresponding side marked congruent to determine congruence between two triangles, okay? So this is a different deal when we're actually doing congruence. Remember when we had this, for example, oops. We had these two guys like this, and they're congruent, clearly, right? But we had, for example, side, right? And then we had an angle in between the two of them. We could actually say that through side angle side, this is congruent, okay? We didn't need to know every single piece of information to make that determination. So the interesting thing is that when we go back here to angle, what we need to know for similarity is that we have all of our corresponding angles congruent. But here, for a triangle, angle means that we only have two of them congruent. Here's the best part of it. I want you to think about why we wouldn't need all of the angles. Oops, this guy's going to crash real quick. Let's go ahead and get that back going. Okay, sorry about that. Back to the inquiry. We have these triangles, correct? And we don't need to have it as angle. That's silly, okay? We don't need to know all three angles to determine that these are similar. Two angles is enough. And I want you to think about why. And again, it's going to be this. In two triangles, it's going to be the third angle theorem. Remember what that was? That meant that because we have two triangles or two angles congruent within two corresponding triangles, the third angle has to be congruent, right? The sum has to be 180. So if two of them are already going to be the same, that third angle has to have the same value. We already did a proof for that. So this almost works as like a corollary of the triangle of the third angle theorem, but it technically is its own thing here. So we're going to make some determinations here. Ready? Okay. This guy is x, y, z. This is r, s, t. Here are my measurements. I've got 21 degrees. I've got 99 degrees. I've got 21 degrees. And I've got 61 degrees. We're going to figure out if these triangles are actually similar. And we're going to explain why. Well, take a look here. If we're going to figure out angle y, maybe that's the only one we really need to figure out. Angle y is going to be equal to the following. It's going to be 21 plus 99 plus angle y is going to be equal to 180, correct? 21 plus 99 is 120. Angle y is equal to 180. So if we were going to subtract 120 for both sides, what we're going to figure out is that angle y is equal to 60 degrees. Okay? Now, I want you to consider this. We're just trying to figure out what this angle is, and we don't necessarily need to do that. Because we already know this angle is 21, this angle is 21. Okay? We know that this right here, angle S, has to be either 60 or it's got to be 99. Okay? Those are the only two options for it. It means that S and R both have to be 60 and 99, right? Well, since R is not equal to 61 degrees or 99 degrees, which in this case is angle y or angle z. Okay? Shorthand mathematically, we can actually just write an equal with a slash through it rather than writing the words is not. So therefore, we do not have at least two matching angles, right? We have only one. So therefore, these two triangles, XYZ and RST, are not similar. Only one set of angles match. And we need two, right? There's no reason to do angle, angle, angle. All we're looking for is two angles because the third angle has to be congruent. All right, now we showed proportionality with altitudes, okay? Which is something that I really want us to get into here. I'm going to show that we have two triangles here that are going to be the same. So here we go. Oops. What we're going to do here is we're going to show that triangle QPR is similar to triangle QTP. Fun line that just happened, right? We know that PT is an altitude, right? What's fun is that when we have an altitude, and what we're going to end up proving here is that this altitude has created, within a right triangle, 3 right triangles, right? We have the original QPR, right? We also have this guy, QPT, and then we also have this one, PTR. Because remember, this is also going to be a right angle, so that'll also be a right triangle, okay? Here's how we're going to figure this out. Ready? It has to do with the following. Angle Q is the same thing as angle Q in these 2 triangles. Why? Because of the reflexive property. It's so funny how that reflexive property we laughed at the very beginning of the course, and now it's such a critical part to so much of the logic that we're constructing. And then now we need to just look at this. We have 2 right angles, and all right angles are congruent, right? So we need to make sure that we list these guys. And we're going to not just say P and T. We have to be specific, because P here, that's 3 different angles, right? So the angle QPT is going to be congruent to the angle PTQ, right? Remember, the vertex is that point that's in the middle. And this is because all right angles are congruent, okay? Therefore, we have 2 congruent triangles, right? QPR, congruent. I'm sorry, I misspoke. We have 2 similar triangles, QPR and QTP, and that's because of the angle. Now, remember what I've done here, guys. Check it out. I've actually done a 2-column proof effectively. Remember when we do these proofs, and then sometimes we can construct it and just put what our reasons were in parentheses. So I could reformulate this if I really desired as a 2-column proof. Okay. Here we go. Let's do more. Just keep showing that these things are similar. We're going to be given that RS is parallel to TU, and we're going to prove that we have triangle SVR similar to triangle UVT. Now, we only have one way to prove things similar right now with triangles. We only have one postulate, and that's angle. So no matter what right now, we have to end with angle. Will I take points off if you actually cite angle at any point in this chapter? And the answer is yes, because you're being redundant. Okay, the whole key with angle is it's an elegant solution here. I'm showing that we can actually accomplish more with less. So 2-column proof, right? We have our statements, we have reasons, right? We restate our given. So we only need to prove 2 angles that are congruent in these 2, okay? 2 angles. So here we go. First of all, remember what happens when we have parallels. What does that mean? It means that we have a transversal here, right? Let me actually do that in black. Transversal, meaning that this guy is going to be congruent with this guy because they are alternate interior angles, right? So that's that giveaway. Remember, anytime that we see parallels. So we're going to have angle R, SV, and that's going to be congruent to TUV. Oops. And that's because of these are alternate interior angles. Next, I think you guys see this. Anytime we say have this sort of thing going on right here, right? We have this type of angle, if you recall. that's called, and these will absolutely be congruent. They're angles SVR. And I hope you just say it to yourself right now as you're watching this. TVU, oops, which are, of course, vertical angles. So we're done. You know why? We now have our two congruent, or excuse me, I keep saying congruent. We have our two similar triangles, triangle SVR and UVT. And that is just because of angle-angle similarity. All right. More thing here. Mr. Granados, who casts a long shadow. It's both literal and figurative for you right there. But the shadow in this case is 3 feet long. And he is exactly 6 feet tall. We're going to try to measure a flagpole here. The flagpole is 17 feet. Excuse me. 17-foot long shadow. How tall is the flagpole? Just considering these two things, right? So, what I have here is the following. I've got a 6 foot tall guy, right? And this is me, very elegantly drawn, and there's a 3 foot shadow right here, right? Interesting thing is that there's a flagpole that we don't know its height, right? Because we don't have a way to climb it, but we can, from the ground, measure the length of its shadow, which is 17 feet. Okay? So, the question is is there enough information here to solve for the flagpole? And rather than just spoon-feeding you the information, the answer is yes. And I think some of you right now see that these two things are going to be proportional. But the question is, why? Well, it has to do with this guy right here. It has to do with Mr. Golden's sun right here, right? Very elegant drawing, I think, that you guys see. And that the rays of the sun at any point on Earth, and right now, I'm on campus at our school, and I can walk over to the flagpole, and I'm going to have a proportionally long shadow, because at this moment in time, doesn't matter when, the rays of the sun that create that shadow, right, are all linear, okay? All these rays are going to be linear as they're next to me, and they're blocked, of course, in the case of the flagpole, which is what creates the shadow on the other side, right? And also with me here. Now, think about this. There's a perpendicular, this is an altitude, right? An altitude is a height. So, of course, altitudes we take as a perpendicular distance. I'm standing straight up, right? So it's not like the Michael Jackson video, right, where he's like leaning, Smooth Criminal. I think I just made a very dated early 90s, late 80s reference that none of you will get, but that's okay. So the triangle here winds up being similar. Therefore, I have a proportion, and here's why. We have one angle here that is going to be congruent. The other thing that we'd have to say is that this angle right here is also going to be congruent, because the angle of the sun is going to, in these rays, these rays that are coming are going to be the same, hit me at the same angle as they do the flagpole. So therefore, these are congruent triangles. Excuse me, I keep saying it. These are similar triangles. Due to the angle-angle postulate. So it's going to be 6 to 3 is equal to, and we don't know this length right here, the height of the flagpole, which is x to 17. And then we just take a quick cross product, right? Oops, 6 times 17, which is a 102. So we have 102 is equal to 3x. We're going to divide by 3 on both sides, and you're going to get 34. So it's going to be 34 feet. All right. That's all I've got for you for today. I'm going to post your assignment on Canvas. Good luck.